Okay, now we go to the second subtopic for chapter 2 is signal APIs. Okay, ada banyak tu kan, signal API. What is signal? Signal is a method to communicate between multiple processes by way of signaling. So the source processes will send a signal which is recognized by number, and the destination process will handle it. So a signal may be generated asynchronously or synchronously. So a synchronous generation occurs when a signal is sent to a process by the kernel or by another process. A process cannot predict precisely when an asynchronously generated signal will be delivered. So synchronous generation occurs when the process itself executes code that directly generates the signal. For example, by executing the instruction that cause a hardware exception or by calling rise. So the delivery of the synchronously generated signal is precisely predictable and it occurs immediately. So real-time signals are a POSIX. POSIX ni apa? Cuba Google POSIX ni apa. P apa, OS apa, I apa, X apa kan. Okay. So real-time signal are a POSIX addition to the original signal model and differ from standard signals in that they are queued. Okay, queue dalam queue have a specified delivery order and can be sent with an accompanying piece of data. Okay, real-time signals are designed to be used for application-defined purpose. Okay, so the BSD signal API. Okay, dengar nama BSD kan? Kita dah install BSD kan? The first week kita dah install BSD. So the POSIX signal API drew heavily on the 4.2 BSD API. Ini pun kita dah tengok 4.2 ni version kat mana kan? Daripada hierarchy, daripada apa? Fork Unix evolution tu. Okay, yang belum tengok boleh Google Unix evolution, dekat Wikipedia pun ada. Okay, kita tengok kat situ cabang-cabang daripada Unix, nama-nama dia selepas dia bukan setakat Unix saja, ada banyak. Okay, so kalau kamu tengok kat situ nanti akan jumpa Linux dan Minix. So Linux dan Minix tu tak ada fork daripada mana-mana Unix, tapi there are Unix like lah. Okay, so dia orang dapat source code Unix daripada mana pun kita tak tahu kan. So the BSD functions are mainly direct analogs of this in POSIX. There are many similarities between the BSD and POSIX signal handling facility because the POSIX facility were inspired by the BSD facilities. So BSD unit has a concept of a signal stack. So this is an Ethernet stack that is used during the execution of signal handler function instead of its normal execution stack. So the BSD facilities are declared in signal.h. Signal.h kamu tahu kan? Programming kamu tahu kan? OS patutnya semua orang kena tahu lah OS kan? Apa itu stack, kernel. Okay? Kalau tak ambil OS lagi susah sikit ni benda ni kan? Okay, C program, kita belajar programming C kan. Okay, signal C kita nak tengok dalam API apa kita pakai. Guna C. Okay, so macam mana kita nak gunakan signal dalam C. Okay, so there is a C signal handling. Okay, first kita guna C abort kan. Signal abort. Okay, C pula dah. Signal abort. So SIG for signal, ABRT is abort kan. So sig abort or abort abnormal termination. Signal FPE. FPE is floating point exception. Illegal ada sig ill kan. Ingatkan demam ke apa kan, ill. So sig ill, illegal invalid instruction. Interrupt sig INT. Okay, interactive attention request sent to the program. Yang ni ada dalam lab nanti. Okay, yang lain-lain kamu kena cari coding dia. Okay, signal segment violation, SEGV ya, SIG SEGV. segmentation violation, invalid memory access. Okay, untuk terminate, okay, signal term, sig term, terminate, termination request send to the program. Signal as a method of process synchronization, auto signal can be viewed as a method of IPC. Many factors make them generally unsuitable for this purpose, including their asynchronous nature. So the fact that signals are not Q and low bandwidth, more usually signals are used as a method of process synchronization and for a variety of other purposes. For the conclusion, signals play an important role in various parts of the system called API.